Okay, hello. Today we're going to do logistic regression and multinomial logistic regression on SAS Enterprise Miner. So I've opened up my SAS Enterprise Miner, and so I'm going to start a new project here. Okay, I'm just going to call it Logistic, and I'll call it mlogit because I'm going to have both cases being running, and as my directory, I'm going to use my normal SAS directory from my C directory. Okay, so once I do that, it's creating and has created, and it seems that it has created successfully. Okay, so now I probably need to load my library where I have my data files, and my data files is located in SAS. So I'm going to create a new library here, and I'm going to call it just mylib. And my location again is going to be my SAS location. So there's where I'm going to use it. Okay. And I'm going to finish it, and everything is set to be used. Now I'm going to select a data source. So my data source is from Retail Relay from the textbook Cutting Edge Marketing Analytics. You can also download this from their website. So I'm going to use Retail Relay 2. Okay. I'm just going to click on enter and finish. So now I have the data set available with me. Okay, so now I have a data set, and it's called Retail Relay. And like I said, this is a text data set you could download from their webpage, Cutting Edge Marketing Analytics. It's called dmanalytics.org. You can probably find it there. And the data set looks like this. Okay. So it seems that it has few dependent variables here, but what we're really interested in the retain, which is the dependent variable that we will be using. Okay, so which means that whether this customer has been retained as a customer or not retained as a customer, and there are several types of independent variables that we can use. Okay. And I think we're probably interested in the average amount that they have been using. And by the way, I actually created a group of variable that is not included in the original data set. This is just looking at how many amounts of dollars they have used and try to see that in terms of groups. So that is, if you are in group 1, you are somebody who spent less than $100 per order. And if you are in group 2, which means that you have spent on average between 100 and 200, and if you are in group 3, meaning that you have spent more than $200. Okay? So now kind of having that in mind in terms of how our data set looks like. So now we are going to run a logistic regression. So the first thing that we have to do on SAS Enterprise Miner is to draw a canvas. So I'm going to call this just my can. I'll call it my canvas. Okay, so now I would get a empty canvas shortly. So there we go. And the usual steps for SAS Enterprise Miner is drag and drop. So first I'm going to drag and drop my data, and now I'm going to go to the model here. In order to run the logistic regression, I have to go to the regression node right here, which is on the model tab and the third node from the right. Okay. So now I have a regression node and I have my data node, and I'm just going to connect my data to my regression node. As of now, if I run the regression, it's not going to work. What I need to do is that I need to specify what my data would be for independent variable and dependent variable. So I have to set my independent variables and dependent variables from the retail relay by right-clicking and edit my variables. So I'm going to do just that. Okay, now you probably notice that there are a lot of different roles that to be given here. Remember, I'm going to use retained as my dependent variable. So that's going to be my target. Okay, but however, in terms of a level, this dependent variable only has two outcomes, so I'm going to specify it as binary. Okay. All the other things are the same, but I'm going to just specify as binary. On the first case, I'm going to run as my order amount as my independent variable. So that's going to be still my input, but all the other stuff, I'm going to just not use it in my logistic regressions line. So what I have to do is I have to put all these into labels, meaning that I'm going to not use as my independent variables. If I use them as input, what SAS Enterprise Miner is going to assume is that this is going to be a independent variable, and they'll run it in the logistic regression line. So everything else that I do not want to include as an independent variable, I'm just putting it as label. Okay. So now I have clicked everything, so I only have my dependent variable as retained, and my independent variable is average order amount in dollars. Okay, I'm going to click OK to that. Now I'm ready to run, but I just need to check one last thing. So if I click on regression, I have property and values, and if I go down, and you will probably notice that there's a class target here, and you have noticed that there is a regression type and there's a link function. Okay, and I want to set this as logistic regression, but if you haven't touched anything, then this would be your logistic regression, and I want to use my link function as logit. Okay, but if you can you can change it to linear regression if you want, and you can always have some different type of link function, probit or clog log, but I'm going to use logit for now. Okay, it seems that now I'm ready to run, so I'm going to run this. Okay. Okay, now it's probably ready to run, and it is currently running. Okay, SAS Enterprise Miner takes still a few moment or so to finish, and it seems that it has run completely, and I'm going to look at my results. Okay, so it seems that this is the results that I get. I'm going to go to my output here, and I'm going to look over to my regression line and its odds ratio estimate. So this is my estimate for average order. It has an estimate of 0.000467, and it also has an odd ratio of 1. So it seems that in this case, making an additional order in terms of dollar to your average order amount, it really doesn't help you in terms of your odds ratio, because remember, odd ratio is the probability of retained over the probability of not retained. So it seems that that is equal to 1, which means that the two probabilities are equal. So it's really not helping in terms of your spend and your whether you are retaining that customer or not. Okay. So in this case, let's try to look at a different variable that might be probably more important. And this time, I'm going to use number of emails that I have sent. Okay, so I'm going to use this as my independent variable. So I'm going to put this as my input. And I'm not going to use order again, so I'm going to put this as my label. Okay. Now, having that in mind, now I want to see whether the number of emails that I have sent to the customers, whether that has a positive increase in terms of whether that they will be retained or not. Okay. So I'm going to now run this logistic regression again with the new independent variable. Okay, now it is running and the regression is running again. Okay, now I can probably see the results. And this is the results. Okay, and I'm going to go down and try to look at my estimates. And these are my estimates. Okay, so number of emails sent, it seems that it has a point estimate of 0.2052. If I look at the odds ratio, it's 1.228, which means that if I do send a additional email to the customer, it seems that the odd ratio of being retained over defecting, not being retained, is 1.2228. So it seems that there is an increase of probability in the odds ratio. So that seems nice, and it seems that this is a very significant value. So it seems that the more that you send your email to your customer, it seems that it is helpful in terms of retaining your customer. So that seems quite positive. Okay. So now let's try to do a multinomial regression, okay, which means that your dependent variable doesn't have two outcomes like retained. It's like for retained, it's 0 and 1. Maybe in this case, we want to have multiple outcomes. And remember, there was the group variable, which has 1, 2, and 3 as three different type of outcomes. So in that case, we want to use this group variable as our independent variable. I'm sorry, dependent variable. So because remember that group was 1 if you have an order of less than $100, and you could be group of 2 if you're between 100 and 200, and your group of 3 if you have more than $200 per order. Okay, so you kind of might want to make a segmentation in terms of your customers. So now let's use that as our dependent variable. Okay, so I drag and dropped another data set, or it's actually the same data set, but I'm going to use a different type of regression. And in this case, I'm going to rename this as not regression, but I'm going to use this as multinomial regression, logistic regression. Okay, so I'm going to just say M logit. Okay. So I'm going to connect the two again, okay? And I'm going to have to edit my variables again, okay? So remember, I'm going to use group as my dependent variable. So this will be my target. And in terms of the level, it's not binary this time. I have to do nominal because I have more than two outcomes. So it's not nominal. It's not binary. It will be nominal, okay? And in terms of my independent variable, I'm going to use doorstep. Okay, doorstep meaning that whether this customer has used doorstep service for their delivery service. So I'm just going to try to see that if somebody has using the doorstep delivery service, then whether they have a better probability of predicting my group my group variable. Okay. So all the other things, what I'm going to do is I'm going to have to put it as a inactive variable. So it's all at input right now. So besides doorstep, I'm going to put all of them as label here. Okay. So I'm going to put all the variables as label. There we go. And the only dependent variable right now is group, and that is, remember, nominal. And my independent variable will be doorstep, whether you have applied for the doorstep service or not. And that is my only independent variable. Okay. So I'm going to click OK, and now I'm going to run this. Okay, my Enterprise Miner is currently running. It's taking a little bit time, but now it seems that it's finished. So now I'm going to go look at my results. Okay, so these are the results that I get. I'm going to go down to where I could see my estimates. Okay, so it seems that this is the estimate that I see. Remember, for doorstep, there were 3 groups that there was. Okay, but it seems that reference 1 is my first group. Okay, so it doesn't report my first group as a result. But however, I get results for doorstep 2 and doorstep 3. Okay, so let's look at doorstep 3 first. So and it has a point estimate of 1.3577, and my odds ratio is 3.887. So which means that in this case, doorstep 3 in reference to doorstep 1 is 3.88 times more likely to have the probability of using the doorstep service compared to the group 1. So which kind of makes sense, because remember, doorstep group 3 was somebody who is ordering more than $200, and group 1 is somebody who is ordering less than $100. So the more that you purchase, maybe they have a higher purchase, which is a little bit more heavier, so you are more likely to probably ask for a doorstep service. Okay, and that is also quite true for group 2. So compared to group 2 and 1, in this case, the odds ratio is 1.438, which is probability of asking for doorstep for group 2. It has a odds ratio of 1.439, more likely than the probability of asking for doorstep service for group 1. Okay. So that's my odds ratio, which also makes sense because group 2 is somebody who is ordering between 100 and 200, and they are definitely more likely to probably ask for that service than somebody who is ordering less than $100. Okay. So in this example, we went through logistic regression and multinomial logistic regression, and you can probably try to change your variables around, your independent variables around, and so on. And you can probably run your own logistic regression and multinomial logistic regressions. Okay. All right. Well, thanks for watching this video.